All right, we're going to begin our journey into the magical world of multiplying binomials with multiplying binomials using tiles. Now, I know a lot of you are like, ugh, tiles are the worst, but tiles are a really good way for you to see what's happening and see why it's happening. Also, you're required by the state of Texas to know how to model with tiles, so let's just do this. So what we're going to do is we're going to tile with the actual tiles, with the physical tiles, okay? We're going to use these physical tiles, and then we're going to copy down what we tiled on the paper, okay? Because obviously I can't have you be like, here you go, here's some, look, this is what I can't, that's not going to work out, okay? So I need you to be able to tile, but I also need you to be able to write down what you saw, okay? So first of all, let's talk a little bit about the tiles. We have three kinds of tiles that we're going to be using, all right? So here are the three tiles, okay? We have, oopsie, I went too far. We have ones, x's, and x squareds, okay? So some things that you're going to notice about the tiles. First of all, they're all like one color on when they're positive. They're all different color, but they're all red when they're negative, okay? And in order to flip the sign, we literally flip the tile, okay? So I have yellow and red as ones, and you may recognize these. When you were in 6th grade, y'all might have used round ones about the size of a quarter, round ones that were yellow on one side and red on the other. We're using the algebra version of this. The x's are green when they're positive and red when they're negative, and the x squareds are blue when they're positive and red when they're negative. Now the other thing that you're going to notice about the tiles is the one, the one constant is a perfect square, perfect little square. The x is one square wide, so they fit together. And the x squared is 1x wide. So these tiles are designed to fit together. They're algebra tiles because they are designed to model algebraic equations. They're designed to model quadratic stuff and linear stuff if you're not using the quadratic tile. That's what they're designed for. They're designed to fit together. So we're going to talk today about how exactly they fit together, okay? So the first thing that's the most, when we model with tiles, we use a frame. So I'm going to draw this frame so you can kind of see it. So the frame, what the frame does is it kind of helps us figure out where our tiles go. We use this frame for multiplying. That's why I put a multiplication sign up in that corner. All right. So what we're going to do is we're going to take one of these problems that you have on here and we're going to tile it. So the first one we have is we have 2x plus 3 times x minus 2. So the expression looks like this. Hold on. I guess I can't zoom out any further. So it looks like 2x plus 3 times x minus 2. That's what it looks like. Okay, and we're going to model this with tiles. So the first thing that we do when we model is on the outside of our model, we write down what tiles we have. So I'm going to start, because I have two x's, so I'm going to put down two x's and 3 positive tiles. So 3 positive ones. Okay? So that's what, now, the question you may be asking, does it matter where I put them? No. I can put the 2x plus 3 here, the x minus 2 there, I'll get the same answer. It just may look a little different. Oh my gosh, this doesn't matter. Okay. All right, now over here on the left side, I have x minus 2. So instead of putting them the ones positive side up, I'm going to put them negative side up. So I have 2 negatives here. All right. So these are my factors. So you remember in our notes a couple of days ago, we talked about how factors are on the outside and the products on the inside. This is what I was talking about. When I'm talking about the box or I'm talking about tiling, the factors go on the outside of my model and the area or the product, so these would be my dimensions, 2x plus 3 and x minus 2 length and width, or these would be my factors. My product goes on the inside. So I multiply my tiles together to get my product, which is on the inside of my box. Okay, so now we could actually start by writing that down. So why don't we pause for a second and write down what you see. Somebody needs to go to the front office. All right. What am I talking about? This is an optional video. So if we wrote it down, I mean, it would look kind of something like this. So it would be like a little T with the tiles on the outside, and we'll talk about how to write them. We talked about how to write them today, so we don't need to worry about that. Now, when I look at the tiles, okay, Okay, I can't put a 1 here, right? Because whatever I put here has to multiply and fit in this same space. A 1 doesn't fit. An x doesn't fit because it's x on one side but 1 on the other. But the x squared does fit because it's x long on each side. So x times x gives me an x squared. Well, I have another x squared right here because x times x. So I've got 2 x squareds right now. All right, now, when I look here, again, an x squared is not going to fit because it's too long. A 1 isn't going to fit because it's not long enough. So here, I'm going to be putting an x because x times 1 is x. But these are negatives, right? So I'm not going to put it positive side up because positive times negative makes a negative product. So remember, you got to think about what your signs are doing. And then here, same thing. Positive x times negative 1 gives me a negative x. And I can fill in these in the same way. Okay, now, scooch these down a little bit. Now when I look over here, the same problem. If I put a 1 here, that's not going to work because it's not long enough. Now, am I going to put a negative here? Well, no, because positive times positive gives me positive, so I'm going to have the positive side up. And likewise, I can do the same thing in these last 2 spaces. Now down here where my 1s are, I'm gonna look. So I have positive times negative. So that means, because the 1's the only thing that fits in this space here, so I'm going to put 6 little 1s down here in this corner. Okay? So what I've modeled here is 2 x's, 3 positive x's, 2x squared, 3 positive x's, 4 negative x's, and 6 negative 1s. So let's just kind of let's skip over here for a second. So the first thing that I could say looking at my model, sorry, I just dropped my pen, is that 2x plus 3 times x minus 2 results in 2x squared, positive 3x's, negative 4x's, and negative 6. So I can see that right here. But we got some like term action here. And remember when we did this stuff right here, how we canceled out, it was right here, how we canceled out 0 pairs? Well, we're going to do the same thing here. So I'm going to look for 0 pairs. I don't see anything where my x's can cancel out, right? Because these are both x's, they're both positive, nothing can happen there. My 1s are all negative, so I can't cancel any of them out. But if I look here, I've got a negative and a positive. So I can take one of my negatives and one of my positives away because they cancel each other out. I've got another negative and positive that I can take away because they cancel each other out. And another negative and positive I can take away because they canceled each other out. So these are gone now because they canceled away. So what's left? Well, what's left is still got those 2x squareds. I've got a negative x and negative 6. And that's my final answer for this particular modeling problem. Okay? I know this modeling video seems really long. It's just that it's modeling is something you maybe haven't done, definitely haven't done with this. So I'm kind of I want you to know how to do it. All right? So, okay. All right, something's happening next door. I don't know what it is. Okay, so I'm going to pause for a second. I'm going to reset my board, and we're going to do one more. Maybe I am. I don't know. Am I? Okay, I'm ready for more. All right, so when we look at this now, if I look at this one, I have x plus 2 squared. Now, again, I told you this before with another type of problem, I can see into the future. Some of you are going to try to get extra fancy and just square the x and square the 2 and say it's x squared plus 4. No. No. Every time you see something squared like this, you need to expand it. X minus 2, x minus 2. And that means I'm going to put, okay, I'm sorry, it should be x plus 2. Ms. Schulteis just corrected me. So I'm going to put x plus 2 there. I'm going to put x plus 2, whoopsie, over there. All right, so I'm going to set up my tiles first. So I have an x and 2 positives, an x and 2 more positives. And again, some of you are right now thinking the answer is x squared plus 4. Let's see if that is the case. Ooh, I need one more tile. No, I don't. Okay, so first of all, first thing I'm going to do is I am going to look. What can I fit in this space? Well, it's x long on each side, and the only tile I've got that's like that is x squared. Okay? Now I got to figure out what to do here. Well, it's 1 wide and 1 x long, which means it's got to be an x. Now, is it a positive or a negative x? Well, positive times positive makes a positive, so I have to put down a positive x. Whoopsie. Oh my gosh, everything's happening. Things are going. And then I would do the same thing right here. Okay? Now over here I got the same thing. This one's 1 tall and 1x wide. Again, the only tile that'll fit in this space is 1x. Now over here I've got a bunch of little spaces. So I've got a positive, a positive, a positive, and a positive. Okay? So I'm just going to kind of like scooch this here. So my x squared, x plus 2 times x plus 2 ended up having, and again, when I look at my product, I'm only looking inside here. I have an x squared, 2 x's, sorry, and then I've got 2 more x's and 4 1's, okay? So now just like I did before, just like I did here, I'm going to look and see if there's anything any 0 pairs I can get rid of. Everything's positive, so I have no 0 pairs, so there's nothing I can get rid of. So I'm going to look what I have written down. So I have 1x squared, 1, 2, 3, 4 x's, and 4 1's. That is how we multiply with tiles. That's what we did in class today. Hopefully after we do the lesson on the box, you'll understand how the box and the tiles are related, but I hope this was helpful.